Hello class, today we're taking a look at our percent unit summative readiness guide. First thing we did in the unit was we dealt with converting between fractions, decimals, and percents. And the main idea here is that your percent sign or the word percent means out of 100. So anytime I see a percent sign, like in 0.2%, I can keep that number the same, and instead of writing the percent sign, I'm going to write out of 100. And that's a good start. Now, with a fraction, we know that a fraction means dividing, so if I wasn't sure what my 0.2 out of 100 was as a decimal, I can go on my calculator and I can just do 0.2 divided by 100. And that'll give me my decimal of 0.002. For my fraction, I am noticing that my 2 here gets to the thousandths place, so I know the bottom of my fraction will be 1,000, and then the digits of my decimal go on top. In this case, it's just a 2. Now that's a good start with my fraction, but I always want to simplify, and I notice that both the top and the bottom here can divide by 2 because they're both even numbers, so I get my simplified fraction 1 out of 500. If I work back the other direction, in the case of 0.359 as a decimal, I'm going to notice that that gets to the thousandths place again, so I could start by writing that as 359 out of 1,000. Okay. Now, I could try simplifying that. 359 divided by 2 doesn't work. 359 divided by 3, so on and so forth. But I'd find that this fraction actually does not simplify in any way. So that is going to be my final answer. With regards to my percent, though, I need it to be out of 100, not out of 1,000. So what do I do to 1,000 to make it out of 100? Well, I'm going to divide it by 10. And whatever I do to the bottom, I'm going to do the top as well. So the top is 359 divided by 10, which moves our decimal one time. And then on the bottom, I've got my 100. Now, since I have 35.9, out of 100, I can replace that out of 100 with my percent symbol, and my number, 35.9, stays the same. So we're just replacing that out of 100 our percent. In the case of the fraction 9 out of 5, again, I can just divide that on my calculator to get the decimal 1.8, and that is my decimal. If I want to make a percent, I need to multiply that 5 by something to get 100, and I know that 5 times 20 is what gives me 100. So I'm going to multiply here top and bottom by 20, and that gives me the fraction 180 out of 100. Once I have my 180 out of 100, I can go ahead and observe that my out of 100 can be replaced with my percent symbol. Again, starting with a percent, we're going to start by replacing that percent symbol with out of 100. So my 75.2% becomes 75.2 out of 100. Now, for my decimal here, I'm going to go ahead and take my calculator. 75.2 divided by 100 gives me 0.752 as my decimal. And if I think about writing that as a fraction, I get to the thousandths place. So it's going to be 752 out of 1,000. Now, I do notice that both of those are equal numbers. So I'm going to simplify that fraction by dividing by 2, top and bottom. 752 divided by 2 gives me 376 out of 500. Those are both still even, so I'll divide by 2 again. I get 188 out of 250, and those are both still even, so I'll divide by 2 again. Get 94 out of 125. Now 125 isn't even anymore, so I can't divide it by 2. I can't divide it by 3, or by 4, or by 5. So it's pretty safe to say that my 94 out of 125 does not simplify further. In the case of the decimal 12, well, really it's 12.0. And we know that a whole number there as a fraction is just out of 1. So our fraction is 12 out of 1. Now for a percent, I want that to be out of 100. So I'm going to multiply top and bottom by 100. And I get 1,200 out of 100. Once I have that out of 100, I can replace that out of 100 with my percent symbol. So 1,200%. Okay, In the case of my next row here, I actually notice that it's the same percent as up above. So I can say that my 180% is also 1.8 as a decimal, just from that previous row. And it is the fraction 9 out of 5 as a fraction. To finish up here, I've got a mixed number, 5 and 3/10. 3/10 is the decimal 0.3. Again, you could get that on your calculator if you're not sure by dividing 3 by 10. And when I add that to 5, I obviously get the decimal 5.3. If I convert that to a improper fraction, I'm in the tenths place. So I've got 53 out of 10 from the tenths place. I want this to be out of 100 for a percent, so I'm going to multiply top and bottom by 10. And that gives me 530 out of 100, which is 530%. Again, replacing that out of 100 with our percent symbol. Lastly, we've got our 0.0013. That gets to the 10 thousandths place, so this will be 13 out of 10,000. 13 is a prime number, so this does not simplify. To get this to be out of 100 for our percent, we're going to divide top and bottom by 100. That'll give us 0.13 out of 100. And with our 0.13 out of 100, that will be 0.13%. Again, replacing our out of 100 with our percent symbol. Okay, that's one of those ideas that just keeps coming up over and over and over again. In question 2, it's our easiest. We want to represent 115.2% on the grid. First thing to do is that we know percent means out of 100, so we want to go ahead and start with squares that are 10 by 10, so that we have 100 squares. We do that, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 by 1, 2, 4, 5, 6, 7, 9, 10. And of course, we'll go ahead and add that in. Now, one of these squares, 10 by 10, is 100 squares, or 100%. Since we're over 100%, we can shade in all of that to begin with, and then we'll actually need a second 10 by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, in this one, we're going to need our 15.2% to get our total of 115.2%. Here's 10 in a single column. Here's another 5. And then I need to represent that 0.2. So when we have that fractional percent, we're going to zoom in on a square. I'm going to zoom in on this one here. Since I'm in the tenths place, I'm going to outline 10 further cells. And in those 10 further cells, I need to shade in 2 of them to be 2 out of 10, or 0.2. Okay, so that's my 115.2. Here's my 100. Here's my 15. Here's my 0.2. Okay, again, zooming in to show that fractional percent. Oops, this should be one further over there. Oops, if you know how to count. There we go. That's 10 squares. Okay, in question 3, this comes off of our purple interactive notebook, solving these percent equations. We always want to start these by converting our words into math symbols to make our actual equation. The word what gets translated into a question mark. The word is becomes an equal sign. Any number stays the same, so 2756 stays as 2756. Our old trick with our percent sign is back. Percent means out of 100. The word of itself means multiply, and 35 is just 35. If we check, we've got our equal sign here, and the question mark is isolated. It's the only thing to the left of that equal sign. So that means we can just calculate on that other side. I'm going to go ahead and do that fraction first. 2756 divided by 100 gives me 27.56. I still need to multiply that by 35. So finishing it off, I'm going to multiply that by 35. And I get the answer of 964.6. So I could say that 964.6 is 2,756% of 35. If I take a look at my next question, again, I'm going to begin by translating. What becomes a question mark? The word percent means out of 100. The word of means multiply. 4.3 is a number, so it's just 4.3. Becomes an equal sign, and 75 is a number, so it's just 75. If I again think about my equation here, my question mark is not the only thing to the left of the equal sign. There's a bunch of other stuff there. That means I need to solve or undo what is being done to my question mark. First thing I'm going to undo is I'm going to undo multiplying by 4.3. The opposite of multiplying by 4.3 is dividing by 4.3, and of course we do that on both sides of our equal sign. On the left side, multiplying and dividing by 4.3 cancels out. I'm just going to put a single cross here for the posted version. And on the right side, we can do that calculation. 75 divided by 4.3 gives us this decimal here. I'm going to write down a couple of digits of that. 17.4418. On that left side, we still have our question mark and we still have our out of 100. Now, the next thing I need to undo is the out of 100 part. Out of 100 means dividing by 100. The opposite of dividing by 100 is multiplying by 100. And of course, what I do to that left side, I need to do to that right side as well. So I'm going to multiply my answer by 100. And I get the answer of 1,744.18%. We'll put 19 rounded to the nearest hundredth per the question. And this is our percent. To finish up there, I'm going to go ahead and convert. So my 0.2 is just 0.2. My percent means out of 100. Of means multiply. What means question mark. Is means equals. And 18 is just 18. I'm just going to move this over so I have a bit more space to work with it. If I look at my equal sign, my question mark is not by itself to the left. There is other stuff here. So I'm going to need to solve or undo that other stuff. First thing I'm going to do is I'm going to deal with this fraction. This fraction can be calculated as a decimal. So 0.2 out of 100 is just the single decimal, 0.002. And now I have to ask myself, what's the opposite of multiplying by 0.02? And the opposite there, of course, is dividing by 0.002. I'm going to do that to both sides of my equal sign. All I'm left with on the left side is my question mark, and on the right side, I'm going to do 18 divided by 0.002, and I get 9,000 as my answer. Okay, so when we're solving, we want to translate our words into symbols, and then we're going to go ahead and follow our grade 7 solving steps. Next thing we talked about was finding our percent change. The formula for percent change is that percent change is equal to end value, subtract the start value, divided by the start value, and then multiplied by 100 to make it into a percent. So for each of these, we're just going to apply that formula for our percent change. In the case of question A, we've got our start value of 35, our end value of 123, and we're just going to fill in our formula. Percent change is equal to our end value, 123, take away our start value of 35, divided by our start value of 35, and then multiplied by 100. If we do that subtraction on top, 1, 2, 3, take away 35, gives me 88. 88 divided by 35 gives me the decimal 2.514285. And then multiplying that by 100 from the formula gives me 251.43 rounded. And of course, that is a percent. So we'd say our percent change from 35 to 123 is 251.43%. Since that is positive, it's a percent increase. Now, likewise, for question B, we're again going to identify our start and our end number, and we're going to fill in our formula. Our percent change is equal to our end number, take away our start number, divided by our start number, and then times 100. 120 take away 126 is negative 6. 6 divided by 126 is 0.047. And then that times 100. Oops, we need our negative there. That times 100 gives me, oops, I don't know what happened there. Let's do that again. I get 4.7619. So we'll say 4.76, and since that's negative, it's a decrease. We're obviously going down from 126 to 120. Okay, so when you're calculating the percent change, just use your formula. For question 5, we're trying to convert our percent change from a number to a percent of our number. And when we wrote in our notes about this, we said that our percent of a number is going to be equal to 100% plus our percent change if it is an increase, and minus our percent change if it's a decrease. So if we have a 10% increase from our number, then we're going to do 100 plus for our increase 10, gives us 110% of the number. For a 15% decrease, we're going to start at 100, and we're going to go down or subtract 15 to have 85% of our number. And then with a 120% increase, we're going to start at 100, we're going to add increase 120, and get 220% of our number. Now, could a percent decrease ever be greater than 100%? Well, it depends on if we have a situation where you can lose more than you have. Okay, so only things that would be able to go into the negatives, for example. So we could have a more than 100% decrease in temperature, for example, because we could go into the negatives in temperature. Okay, anything else where we can't lose more than we have, we would not be able to have a percent decrease greater than 100. Most you could lose is what you have, right? If I have 33 students, I could have 100% of them leave, but I couldn't have more than 100% of them leave. There isn't more than 100% of them to begin with. Question 7, what is the percent change when a 120 centimeter child grows to 180 centimeters in height? All we have to do here is, again, figure out our start and our end numbers and apply our formula. Percent change is equal to our end number, take away our start number, divided by our start number, and multiply by 100. 180 take away 120 is 60. 60 divided by 120 is 0.5. And 0.5 times 100 is 50. So I'd say we have a 50% increase. To finish up, we talked about some situations where we can combine percents, that means add or subtract them, or we can find percents of percents, and that means multiply them. First situation that we dealt with was with GST. GST is government sales tax, and it is 5% of the purchase price or the sale price. Okay. And it's charged on pretty much everything in Canada that is not in essential goods. So you're not charged on food and a couple other things, but any kind of luxury good or a need rather than a want is charged this 5% tax or a 5% increase. Okay. Now, there are two ways to find the total price from your GST. We could find the amount of GST, which is 5% of the sale price, as we said. So do 0.05 times your sale price, then add that to the sale price. Or we can just find 105%. And that 105 comes from an idea of a percent change. Tax is a 5% increase. So 100% of the product plus our 5% increase is 105% of the sale price. We're going to apply that idea for question 9. We have a product's regular price is $75.34. We want to know the final price including GST. Our final price is 105% because of GST of the sale price. If we convert that into an equation, our final price equals 105 out of 100 times our 75.34. That is going to be equal to 1.05, converting that fraction to a decimal, times 75.34, and 1.05 times 75.34 gives me $79.107. Now, dollars always only has two decimal places, so I'm going to round here and say $79.11. Now, if the product is purchased in Ontario, that has an extra 7% PST as well. So that 7% PST is a provincial sales tax. It's still of the sale price. So we're just going to find 7% of the sale price. That's going to be the extra that the Ontarians need to pay. 7% is 7 out of 100 of means times, and then our sale price was $75.34. 7 out of 100 is 0.07 times our 75.34 gives us 5.273, or if we round, 5.27, rounding down. Okay, so the Ontarians will pay an extra $5.27. In our last part of this question, we want to know the final cost, including GST, if the product goes on sale for 16% off. So this is a 16% decrease, and so we could say our final price will be equal to our 105% for GST of our sale price. However, our sale price here is going to be 86% of the regular price. How did I get my 86? It should be 84. And that's from 100 take away 16 gives me 84. Again, same idea as up here. I'm going to start with 100% and I'm going to subtract my decrease. So 100 take away my 16% decrease leaves me with 84. So overall, I'm going to have my 1.05 for my 105% of means times, 0.84 for my 84% of means times, and my regular price was $75.84. And I'm going to do those calculations on my calculator. 1.05 times 0.84 times 75.34. Should get a final price of 66.45 after rounding. Last two questions. Tim invested $200. By the following year, the value had increased by 15%. After that, it increased by another 15% the next year, and then increased by another 10% the year after that. What's the final value of the account? So this is going to be a percent of a percent problem. The first year, we have 15% increase of $200. After that, we have a 15% increase of whatever we had before. And after that, we have a 10% increase of that second year amount. So our final value is going to be equal to our 10% of the second year. That's this part here, which itself was 15% of the end of the first year, which is this part here, and then our another 15% of the start. Now we have actually done something here that we need to just take into account. Each of these would be the amount of change, but we want the amount in the account. So again, we want to add 100 to each of these. So 110, 115, and 115 there. Let's go ahead and calculate that out. 110% is 1.10 as a decimal. 115% is 1.15 as a decimal. 1.15 for the other 115 as well. Then our starting number was 200. Let's multiply all of that out. 1.10 times 1.15 times 1.15 times 200 gives me 290.95. So after those 3 years with those values, we're going to have $290.95. Lastly, the original price of jeans was $72. On the first day, the price was decreased by 25%. We decrease by 25%, it means we have 75% left. On the second day, we decreased by an additional 10%, which means the second day we're going to have 90% of the price left. And of course, it's 90% of the previous day's price. 90% is 0.90 as a decimal of is multiply. 75% is 0.75 as a decimal of is multiply. And then 72. So let's multiply that out. 0.9 times 0.75 times 72 gives me 48.6. And that's going to be my price after the second day. Okay. So I hope this video has helped you with understanding some of our concepts for final price and our percent applications.